All right, back here to continue a few more examples working with the means here. So on this first one here, question 4, jumping around a bit, it says the amounts of nicotine in a certain brand of cigarette are normally distributed with a mean of 0.905 grams and a standard deviation of 0.321 grams. So I've got the mean, also have my hands on the wrong spot on the keyboard, 0.905, and it's the standard deviation sigma 0.321. Just taking the important information so far. The company that produces these cigarettes claims that it has now reduced the amount of nicotine. The supporting evidence consists of a sample of 46 cigarettes with a mean nicotine amount of 0.82. So I have N of 46, and then I have an X bar, the mean of my samples here, of 0.82. Maybe an X bar sub X, something like that, but that's okay. Assuming that the given mean and standard deviation have not changed, find the probability of randomly selecting 46 cigarettes with a mean of 0.82 grams or less. Now, this is a little bit of change in notation, but this is one of the hiccups we're dealing with while we're working with WAMAP. They're not all notated the same. So there's a couple things that happen here. This is going to be kind of our value of interest. That's why it shows up here also. I need to figure out what the standard error of the mean is, and so I'll do that. And it is going to be the standard deviation divided by the square root of n. I'll put my work right here for that. And really what that does is change our standard deviation from 0.321 to 0.04773 for our group. So draw on our distribution here. Try to draw the normal distribution first and then put in our stuff here. So our mean, this should be 0.905. And then 0.82. That's going to be over here, and if we go by 0.47, it might be about 2 of those, so we might be looking at a value here. What was it, 8, 2, anyway. So we're trying to find this area here. Pretty ugly. My penmanship. Anyway, so we have X bar being less than 0.82. Really not doing so great on the penmanship side of this thing. Okay. So, again, kind of back to what we have been doing. We're doing a normal distribution here. We've got a number of interest, 0.82. We've got a mean, and I'm going to just click on these, and then we use the standard error of the mean here. And true, we'll find this area to the left. And so this answer kind of makes sense because we're more than 2 standard deviations away. So we've got a pretty small value here. Around these, 0, 3, 6, 2, followed by a 5 is going to be a 3. And maybe I'll just grab this and make sure if it's a 5. Okay. Sometimes that last digit isn't rounded right. And then it's like gives you problems here. Now we have a little bit more. We can kind of ignore this using exact z-scores. This tells us how to do it. We're going to let Excel do all of the work and then just check the final answer here. Assume that any probability below 5% is sufficient to conclude that the new product really have lower nicotine. Based on the results above, is it valid to claim the amount of nicotine is lower? So we're below 5%. So it is here. Yeah. Okay. So there's one more example worked out. I want to tackle this one here also. It says the particular fruit's weights are normally distributed with a mean of 297 grams and a standard deviation of 26 grams. So we got mu, 297, sigma, 26. Zoom in a little bit here. If you pick 26 fruits at random, So interesting here, our standard deviation is 26 as well as our sample size. Then 3% of the time their mean weight will be greater than how many grams? Okay, so we got a picture here, and what we have happening when it says this, and this can be a little bit confusing here, 3% of their time their mean weight will be greater than how many grams? So we're going to have a little cutoff here, and this over here is the 3%. And remember, our Excel function always gives, we have to input this area to the left. So we got a couple things going on. We need to know this area to the left, or we need to use the complement, like 1 minus 0.03 here, 0.03, right? That's going to be the area here. If we got 3% to the left, then this is going to be 0.97 for this area in here. But we also have a sample size. So our standard error of the mean is going to be equal to sigma divided by the square root of 26 here. Yeah, let's see here. Let's just click this one. Okay. I really want B3, but it's hiding it from me. Oops. So we'll just grab it here. And when I click this, hopefully here, it'll show you we got those guys. Okay. So our standard error here is this one. And now we're looking for a value along this axis. We have an area under the curve. So when I'm looking for that x value, or that weight, it's going to be equal to, we've got a normal inverse. Now our probability, the area to the left under the curve, 0.97. The mean, that's this one. And then the standard error is going to be the standard error of the mean. And this gives us a cutoff. Now we're doing this to the nearest gram. So I'm going to grab this stuff. And I like to let Excel do all the work. That's why I'm not typing in any rounded answers except for right here. This is going to round up to 307 grams. And remember, the mean is 297 here. So 3% of the time, this value needs to be bigger than 297. So we fit for reasonableness sake with a response here on this one. So we're kind of working the same kinds of problems we were doing before in section 4.3 and even in section 4.2, but we're using the standard error instead of the standard deviation. It would be the standard error of the mean. And I'm going to do a couple questions here on the next video dealing with proportions and how we handle those. So let me know if you have any questions. Thanks for watching.